video at the beginning, but we're in section 6.3, radical operations. And what we learned, this is good review for the rest of the class. What we learned is that to add or subtract, you have to have like radicals. That means that the index and the radicand have to be the exact same. So these are like radicals. These are not. This one's not because the radicand is not the same. This one's not because the index is not the same. So when we go to add like radicals, we see here the radical part is exactly the same. So we treat it as if this was 14x plus 5x. Treat the radical like an x and just add the outside numbers like coefficients. So 14 plus 5 is 19 and then keep the radical part. On example 2, at first glance you say, well, I can't add these. They're not like radicals. However, when we look closer, we see, you know what? I can break each one of those radicals down. So I broke down 72 and got 6 square root of 2. When I break down square root of 50, a 5 comes out, but there's already a 3 in front. So I multiply the 5 by the 3 to get 15. And then this little lone 2 is left by itself. Then we have the 8. A 2 comes out, multiplies by the negative 6 that's already there to give us negative 12, and this little loner 2 stays under. Now we have like radicals. Each of those has a square root 2. So I add the numbers in front of the radicals. 6 plus 15 is 21 minus 12 is 9. Keep the radical 2. The same thing applies if we look at cube roots. Remember, with cube roots, we circle groups of 3 of a kind before we take them out. So the same thing works there. All right, now we're going to multiply. How do you think we're going to multiply this? Yeah, you're just going to distribute, just like you would any binomial. Okay, what's our acronym for distributing a binomial to a binomial? FOIL, first, outer, inner, last. So I'm going to take it really slow this time, and then we'll move up. But I have 5 times 4, which is 20. So I did first times first. 5 times 4, which is 20. Then I have 5 times negative 5 square root of 2. Well, when you're multiplying, you multiply the outside parts, and then you multiply the parts under the radical. Here, there's not another number under the radical. So that would just be 5 times negative 5 is negative 25 square root of 2. Now I need to distribute the 3 square root of 2. I'm going to do 3 square root of 2 times 4, and then 3 square root of 2 times negative 5 square root of 2. If you're doing FOIL, that's your I, your inner times your inner. So that's 3 square root of 2 times 4, which is 12 square root of 2, and it's positive. And then finally, we distribute the 3 square root of 2 to the negative 5 square root of 2. Which, if you're doing FOIL, is last times last. Here's where a lot of people mess up, so I want you to pay very close attention. We multiply the outside numbers, 3 and negative 5, to give us negative 15. That's easy. But when we multiply the inside numbers, that's square root of 2 times square root of 2. That's square root of 4, which is 2. So you have to be really careful when you're multiplying a square root by a square root. And then little intermediate step here. What is negative 15 times 2? Negative 30. And then we just combine our like terms. So 20 minus 30 is negative 10. And negative 25 square root of 2 plus 12 square root of 2 is negative 13 square root of 2. Any questions? Lauren? Okay. Lauren says, what if they're different under the radicals? So I'm going to run through one real quick. You don't have to write it down. But I mean, when I say real quick, I mean like super speedy Gonzalez here. So 1 plus 2 square root of 3 times 5 minus 4 square root of 6. Like that? Is that what you mean? So we would have 5 minus 4 square root of 6 plus 10 square root of 3. So we're good to there. But then this one, you would have 2 square root of 3 times negative 4 square root of 6 for this last term. That would be negative 8 square root of 18, which can then be broken down. And a 3 taken out. So you end up with just a really long answer. Because none of those are like terms or like radicals, so you just end up with a really long answer. And that's okay. All right, so here's the one I want you to do by yourself. By yourself, I would like you to try 2 plus 3 square root of 5 and 2 minus 3 square root of 5. Multiply those together. Okay, so when we multiply these out, we get 4 minus 6 square root of 3 plus 6 square root of 3. The one that you're having trouble with is the last times the last. So we have 3 times square root of 5 and negative 3 times square root of 5. That gives us negative 9, and square root of 5 times square root of 5 is 5. Multiply those together and you get negative 45. Now it's time to combine like terms. So our constants are 4 and negative 45, which gives us negative 41. I don't know why that gave me extra marks. Negative 41. And then if we look here, these are our radical terms. We have a negative 6 square root of 5 and a positive 6 square root of 5. Those just cancel each other out. There's no square root of 5 left. Some of you wanted to write square root of 5 on your paper, but that would be like 1 square root of 5. And negative 6 plus 6 is 0. 0 times anything is 0. So your answer is just negative 41. Now there is a special name for this pair. Do you remember the special name for this pair? Conjugate. This is a conjugate pair. We have used conjugate pairs before to rationalize a denominator, whether you realize it or not. So let's rationalize a denominator. To rationalize a denominator, multiply by the conjugate of the denominator, multiply by the conjugate of the denominator on top and bottom. And I'm going to do 2 examples. Because you already know how to do it when the denominator is just a square root. Like if it's just a monomial term, we learned how to do that yesterday. But when it's a binomial term, you might be confused. So 3 over 5 plus the square root of 2. Rationalize the denominator. That's what we're doing. The directions will say rationalize the denominator. Or they may just say simplify. I know I should have been mathy and said multiply by the conjugate of the denominator in the numerator and the denominator, but then I thought all those words might just get confused. So top and bottom. What is the conjugate of this denominator? 5 minus square root of 2. So we're going to multiply both the numerator and the denominator by 5 minus the square root of 2. And so I just multiply. 3 times 5 is 15, and 3 times negative square root of 2 is negative 3 square root of 2. There's your numerator. Why my pen keeps giving me little extras, I don't know. And then in the denominator, we're going to multiply the conjugates like we just did. Now, what should you get rid of by multiplying by the conjugate? The radical part. You should just end up with a constant. You should get rid of the radical part. So, let's see if that happens. 5 times 5 is 25. And then 5 times negative square root of 2 is negative 5 square root of 2. Then we have square root of 2 times 5, which is positive 5 square root of 2. And then last times last, square root of 2 times negative square root of 2. All right, we have a positive times a negative, so it's going to be a negative. Square root of 2 times square root of 2 is square root of 4, which is 2. Look what happens in the denominator. This negative 5 square root of 2 cancels out with this positive 5 square root of 2. So we end up with, for our final answer, 15 minus 3 square root of 2 over 23. Where do you remember doing this? Imaginary numbers. We did it with imaginary numbers. So just like with imaginary numbers, if when you finished, if 15, 3, and 23 could all be divided by a common factor, then you would reduce it. Just like you did with imaginary numbers. Any questions? Let's do one more. Last one. And then you get to practice. So, this one is real fun. It's 3 square root of 2 over square root of 5 minus square root of 2. When I say real fun, I don't mean it. Okay, step 1. What's it going to be? Multiply by the conjugate of what? The denominator. So we're going to have square root of 5 plus square root of 2. And we're going to do the same thing on top and bottom because that's like multiplying by 1. We talked about that yesterday. If you do something in the denominator, you have to do the same thing in the numerator so that you're in essence multiplying by 1. Now let's simplify. 3 square root of 2 times square root of 5. The numbers on the outside, just 3. Numbers on the inside, square root of 2 times square root of 5 is square root of 10. Then we do 3 square root of 2 times square root of 2. So 3 square root of 2 times square root of 2. What does that give you? 6. Okay, because square root of 2 times square root of 2 turns out to be 2. So our numerator is going to be 3 square root of 10 plus 6. I have to add a little extra simplification step here. All right, in the denominator, we do first, outer, inner, last. Square root of 5 times square root of 5 is square root of 25, which is 5. Square root of 5 times square root of 5 is square root of 25, which is 5. Then we do square root of 5 times square root of 2, which is square root of 10. First times first, outer times outer. Inner times inner is negative square root of 10. Are you noticing a pattern here? The middle numbers always cancel out. So if you want to take a shortcut and not even worry about doing outer and inner, the middle numbers, you can. And then last times last, what is square root of 2 times square root of 2? Square root of 4, which is 2. We have a minus and a plus, so that's going to be minus 2. These cancel out, and so we just have 3 in the denominator. Can I simplify that any? Yes. We can divide them all by 3. So 3 square root of 10 divided by 3 is just square root of 10. And 6 divided by 3 is just 2. Do I need to write over 1? No, in fact, that would be wrong. That would be unsimplified. Any questions? I'll turn the recording off.